All right, we are back with another episode of Mining Now. I'm your host, Jerrod Downey. Today on the show, we have Expert Geophysics. Pretty amazing company. If you haven't seen it, we'll do some intro. Stay tuned. You'll see some very unique pictures, to say the least, of some of the devices that they're using. Today on the show, we have Aamna Sirohey. She is the data processing manager for Expert Geophysics, and Andrew Carpenter. He is the regional manager for the company. So, Aamna, Andrew, welcome to the show. It's great to have you on.
Thank you so much for having us.
It's great to be here.
Where's everybody located? Two different countries, I believe, right?
Yeah, I'm in Ontario, specifically London, Ontario.
And I'm in Perth, Western Australia.
What's Eastern Canada like right now, Aamna?
It's all right. The weather's finally turning into something resembling summer, so it's good. Hopefully winter's gone for now.
We just did CIM, and the teams were from back east were very large. So I think a lot of people were trying to hitch on to come out for some Western weather.
Yep, understandable.
Yeah. Sorry, whereabouts are you located again, Andrew?
Perth in Western Australia.
So what time is it there right now?
7:30 in the morning.
Oh, we made you get up early.
You did indeed.
My apologies. Okay, let's jump into it. It's good to have you both on the show. Expert Geophysics, let's give the snapshot of it first. Andrew, let's start with you.
Sure. So Expert Geophysics is an airborne geophysical company. We specialise in airborne geophysical surveys, and we use very advanced electromagnetic systems. We're offering the latest innovations in airborne electromagnetic technology, and we specialise in mobile MagnetoTellurics. And our premier system is the MobileMT system, which is the most advanced generation of airborne AFMAG technology. MobileMT combines latest advances in electronics, airborne system design, and sophisticated signal processing techniques. And we basically go out into the field, we acquire the data for our clients with our technologies, we process that data, and then interpret the MobileMT data. The MobileMT method is applied globally for mineral, oil and gas, and geothermal exploration.
Alrighty, so let's take a moment to thank our sponsors. First up, we have Micromine. As your mining projects accelerate, so should your technology. Micromine is a leading software provider to the global mining industry with solutions that support the entire life cycle from early exploration to advanced mine operation. Micromine enables explorers to prospect smarter, model faster, and estimate with greater confidence. They empower mining engineers to optimize strategic mine planning, streamline design, and schedule faster. Micromine's technology supports even the largest mines to gain greater operational control and boost performance. And they provide mining teams with reliable data management solutions to enhance insights, meet compliance, and safeguard digital assets. To learn how Micromine's next-generation technology can help you, visit their website at micromine.com today. Next up, we have OptiSeis. OptiSeis is a leading-edge geophysical acquisition design and software company. OptiSeis provides innovative seismic survey designs, utilizing the latest field technology and optimizing for advanced processing and quantitative interpretation techniques. OptiSeis' mission is to bring sustainable exploration solutions to energy development with their custom land footprint reduction technology, EcoSeis. EcoSeis enables operators to focus on reducing their environmental and greenhouse gas footprint while imaging all their subsurface targets and reducing costs. Visit them at optiseis.com to learn more. We also have process automation. Process automation is a byproduct of the massive South African mining industry, which was served from conception and grew into a leading mass measurement instrumentation manufacturing company. Process automation is the original equipment manufacturer of conveyor belt scale, density gauges, wayfeeders, level gauges, blocked chute detectors, speed sensors and switches, and bin, silo, and hopper weighing systems. Their strengths are in their expertise, professionalism, and strong focus on after-sales support. This results in a successful outcome on every project. To learn more, go to process-auto.com. Process automation. If you can process it, we can measure it. Of course, we also have Edge Eyewear. Edge designs stylish, quality, and affordable safety eyewear that's as fit for the weekend as the workday. Edge safety glasses and sunglasses are ANSI or CSA compliant, come ready with modern technology, and are comfortable enough to meet the unique protective requirements of those in the mining industry. And they've been delivering a better safety glass since 1998. Visit edgeeyewear.com to learn more and save 20% with the code CROWN20. And last but not least, we have SolarSet. SolarSet has launched pre-assembled ground-mounted solar systems, including the innovative SolarSet Fold. Their solar systems will power your residential and commercial property, and they also ship worldwide. Talk to their team to learn if a grid tie or off-grid with battery backup solar system is right for your application. Visit them at solarset.com to learn more. Now let's get back to the interview.
So I'm going to call them for now. We're going to highlight them, bring some images up in that. So these contraptions, that are out there, is that something you designed in-house? Is that actually the company that's built and made those?
Yeah, sure. Look, we've got the most important part of our company is research and development, and we build all of that technology in-house.
Wow.
Yeah.
Can you give me a little background on the company? Sort of where it got started, how long it's been around, things like that.
Sure. So the company's only a new company. We started in 2018 when we flew our first MobileMT survey in July. And at that time, we only had one operational MobileMT system. And now we've got 8 operational MobileMT systems. We've got another technology, MobileMTM, which we can talk about a bit later, I guess. And we've got 2 operational MTEM systems. And as we speak, we're building additional systems. So I think in the workshop at the moment, the guys are building 2 more MobileMT systems and 2 more MobileMTM systems.
That's quite a bit of growth. What is it? Is it the ease of use? Is it the service? Where do you think that all that growth is coming from, and that increased demand? Because 2018 is not very long to have that much demand for a product.
Sure, it's a combination of things. It's a very unique technology, and we're offering a very unique tool for our clients. And the system is very easy to mobilize and use. So the combination of those 2 things have seen us undergo some very rapid growth.
Aamna, I know you're really the expert in the actual technology. Can you sort of just walk us through the application of the technology, what it's used for, and very, right at the core, I mean, myself and a lot of people watching really are going to be not at a high level like yourself. So would you be able to sort of walk us through really what the technology does?
Yeah, sure. So I'm not an expert by any means. The experts are the guys who are part of our leadership team. But before I get into the specific applications of our specific system, I want to talk a bit about the Airborne EM industry and the tools that were already existing. So broadly speaking, there are 2 types of electromagnetic systems. One type depends on controlled sources, and then the MobileMT system and systems like it are dependent on natural EM fields. So the limitations of controlled source systems is that you have to install a transmitter on the aircraft. And obviously that's limited in terms of the energy you can transmit for safety purposes. And the other thing is it's critically dependent on the height above the ground that you're flying. So it makes it not very useful in certain terrain conditions. So if you have a lot of topography, it's really hard to maintain a very close clearance to the ground. So MobileMT was developed to overcome those challenges. And because it relies on passive fields that are generated mostly by lightning activity worldwide that energize the ground, and then instead of having a controlled source transmitter, you're exploiting these natural fields, we're able to fly higher above the ground and still get a good response, making the system useful in rugged terrain conditions. And we're also able to survey in geological environments that previous systems could not, because again of limitations with controlled source transmitters. So in very conductive environments, where your signal is attenuated very quickly with depth, the MobileMT system is still able to get a superior depth range in such environments.
So you said there's an older, like the technology, some version of it has been around for quite a while then?
Well, so the field of airborne EM has been around for a while, and most of the attention has been focused on controlled source systems, just because the actual technology and mathematics for using passive fields was not really developed, or the technology was not available. So this system, like Andrew said, it's extremely unique, and the hardware and the software that goes into processing the data and ultimately acquiring the products that then clients can use for interpretation purposes. It took a lot of kind of innovation and thinking about how best to design the hardware so that we're measuring the best signal, and then also how are we going to process that data to derive a good product to provide to the client.
And I think this sort of you see this a lot, especially in the mining sector, is that the hardware company is also the technology company and also the data collection and process company. And that's really what you're doing. You are making the hardware, but at its core, you're trying to get data and then redistribute that data in a meaningful way.
Yeah, exactly. And the technology itself, for example, our MobileMT system, the hardware consists of an airborne receiver, which measures the variations in the magnetic field, and that's towed by the helicopter. And then we have a stationary base station. So in these two places, whenever we're doing a survey, we're acquiring airborne magnetic data and base station or reference electric data. And then the mathematics that goes into merging that data and ultimately the mapping parameter that we're looking for, which is apparent conductivity, the mathematics that we have to apply to get that time series data into a format that's actually useful for exploration purposes is extremely sophisticated and extremely proprietary. And it's kind of like the bread and butter of the technology and what makes it very unique.
So I'm looking here, I've got a graph here that you sent to me, and I'll be honest, I do not know how to read it, and you will have to walk me through it. So it's got, I can't even say a couple of these words, like orogenic gold.
Yeah, orogenic gold, epithermal gold, uranium. We've done projects for
I can see kimberlite pipes,
kimberlite
gold.
pipes, multi-phase gold. But I guess the biggest thing that we want to emphasize is that we've used the technology for all of these various different commodities that we've listed. But the fact that the system is so versatile and so applicable in such a wide range of both topographic, geographic, and geologic conditions means that really, if an EM, an electromagnetic survey, is suitable for what your mining and exploration objectives are, the MobileMT system can most likely deliver the results that you are looking for.
Right. So can you just walk us through, because I just went to we were just at VRIC, and then there's PDAC coming up, and you walk and you see all these kind of graphs, and my job is asking people questions. So I watch people that go past the booth, and I can tell that they do not know what they're looking at, just by the way. So they're interested, but they just don't get it. Yeah. And they don't want to talk to someone at the booth necessarily, because they don't want to be pitched the mine. So they just kind of I can see them kind of poking around, trying to figure out I'm one of those people sometimes. So what am I actually looking at? Like, let's pick one. The orogenic gold. What am I looking? Why is this significant, this image?
Well, the image is significant because it's actually demonstrating to you. So I think what you're looking at is a resistivity section. So we acquired like I mentioned before, the parameter that we extract from our acquired data is apparent conductivity. And we extract this parameter for a number of different frequencies. And if you think about it in a way, the electromagnetic waves that we're measuring, they are covering a broad frequency range from 20 hertz to 27,000 kilohertz. The 20 hertz data is imaging the most deep structure, because the longer the wavelength, the less it's attenuated as as a function of distance or depth. So when we have that data, it's not easy to interpret it because the actual relationship between frequency and apparent conductivity is quite complex. So through inversions, where it's just basically modeling. So what we're measuring, it's related to the subsurface structure, but it's not exactly kind of one-to-one. It's not going to tell you exactly what the geology is. So we use complex mathematical relationships and things like that. And then we convert the frequency apparent conductivity to resistivity depth, which then is easier to interpret from a geologic point of view. So that section you're looking for, actually, it's a really interesting example because it shows an area where we have a very thick layer of conductive overburden. It's about 300 to 400 meters. And underneath that, yeah. And underneath that, then you can see there's kind of like a structure or like a bit of a conductor underneath, like the yellow color in the rest. And that actually helped in that project to kind of better delineate the controlling structures on the mineralization in that area. And so understanding that deeper geology then helps you to better understand kind of what your distribution of mineralization is going to be. And then it helps, you know, geologists and people who are involved in the exploration kind of better strategize where potential targets are, and then, you know, drill, and helps to avoid, it just makes it easier to understand the distribution and what you're seeing in terms of mineralization.
You know, as many of these charts as I've looked at, I've never actually had someone walk me through it, which is absolutely, it's almost a little embarrassing, but but it's very helpful, because when you all of a sudden now you're looking at it and I'm starting to see it, as the audience would be. Okay, Andrew, let's get into, let's kind of break down, we've kind of touched on them, but I just want to kind of list them out so we know. We'll bring pictures up so the audience knows. So what are the technologies that we're talking about here? Like this specific, like the models, we've touched on them. I just want to kind of reiterate them one more time before we go on to a couple other things.
Sure. So we've got three primary technologies that we're flying. So two of those are based on the mobile MagnetoTellurics. So the first system is the MobileMT system, which is our flagship system. And that system is exploiting passive EM fields rising from lightning events and thunderstorm activity worldwide. And that's causing variations in the Earth's magnetic field, which is what we're measuring. So that's our primary technology. We've got the MobileMTM system, which is a further development of that technology. And that's built to identify discrete targets and structural features with a focus on the relatively near surface depth range. So that's got a nominal depth of investigation of the system within a few hundred meters of the surface, and in some cases down to a kilometre. And then the final system that we're currently flying is the MTEM system, which is a time domain system. And that's designed for very detailed near surface investigation, so within the first few meters of the surface. And what differentiates this system is its ability to reject industrial noise and electromagnetic disruption, which is a very handy thing to have if you're surveying around built up areas and factories and transformers and all those sort of things.
So, okay. Okay, now were those built in order, like from the flagship, which was the Magneto? Was that the first unit? And now what did you say? The MTEM? Is that the final one, or have these been built together? When you call it a flagship, is that because it's first or because it's sort of the largest one?
It's the MobileMT system, which when people can have a look at some of the pictures, is the big orange bomb, I call it. It's a big orange bird. That was the first system that the company built. The MTEM system, the time domain system, I believe was developed soon after that to address a specific need for some clients who had some specific requirements for their surveying. They really wanted to delineate some information from near surface data. And the MobileMTM system is a further development the MobileMT system. Once again, there was a specific needs that some of our clients had, and our R&D team addressed those by modifying the technology and developing that system. So,
if you're in an Aamna, maybe this is a question for you. If you're in an industrial area, if you don't have a system that can filter that out, and maybe you could explain a little bit more how that actually works. I mean, is this a very, very difficult procedure to actually get that data if you don't have that type of system?
Absolutely. I mean, if one of the biggest issues with EM systems is that obviously any infrastructure, power lines and things like that, they're generating their own electromagnetic signal. And whether you have a controlled primary source or if you're using passive fields, in either of those cases, it's possible the data is going to be affected by power lines. And the extent that the data is going to be affected, it varies. It varies depending on the system. It varies depending on the environment that you're in. Some places have very clean power line signal, so then you don't have too much. Like I mentioned, we record data from 20 hertz to 27,000 hertz, and the power line frequency is usually 50 or 60 hertz, depending on where you are. Sometimes it's just limited to there. Other times it can affect the entire frequency spectrum. So this advantage of MTEM, which is specifically designed for very near surface applications, I think it's more of a geotechnical tool than for mining, but it could potentially be used for near surface mining, mineral exploration activities too. But it's a very big development in the industry because it's kind of a recurring problem that people are always facing and trying to address and overcome.
There is I want to bring up another chart here. It's the AEM depth of investigation.
Mm-hmm.
Can you again walk us through what we're looking at, why it's significant, and just sort of showcase it for us?
Yeah, for sure. So like I mentioned earlier, there's different types of systems in the airborne exploration EM market. Most of the currently commercially available systems are dependent on controlled primary field sources. So the source of energy that is used to energize the ground and then produce a response is located on the helicopter, or not on the helicopter, but on some apparatus that's towed by the helicopter.
Yeah.
In those cases, you can imagine the higher you are from the ground, the more your signal is going to be attenuated, thus the less it's going to be able to energize the ground and the shallower your response is going to be. So this chart, basically, it shows you all of the main types of systems currently available. So you have VLF, which is very low frequency, and this is the signal for this comes from radio transmitters worldwide that emit signal at a very specific frequency. These are usually in the tens of thousands of hertz. You get very near surface geological information from this. So you can see here in both conductive and resistive environments, you're getting less than 100 meters.
Yeah.
Then you have frequency domain methods.
Sorry, is that 100 meter? When you say 100 meters, that's a radius?
No, depth.
Depth. Okay. Depth.
Yeah,
okay.
yeah. So yeah, when you're energizing the ground, like how far below the surface can you see? Then there's frequency domain methods, and they are also severely limited in terms of their depth of investigation. That's what's really limited their use. Time domain systems have a greater depth of investigation than frequency domain systems, but time domain systems have a whole suite of other issues, especially when you're in resistive environments. So like sometimes if you want to do a survey in the Canadian Shield or that kind of an area, time domain systems aren't able to resolve resistivity differences if you're looking at thousands to tens of thousands of ohm meters. And then also sometimes if you have near surface conductors, there's certain effects that corrupt the response that the ground creates and completely basically nullify the response. So it won't work.
So why would that be though?
It's because there's these two effects. It's the IP effect and an SPM effect. And basically what happens is that the ground produces a response in one polarity, you can kind of think of it. And then this corrupting influence, which is, we don't want it to occur, but it naturally does occur, it kind of negates the response that we're looking to measure. And so instead of then producing a conductive anomaly, it kind of just cancels it out and you won't see anything there. Whereas MobileMT doesn't suffer from this same issue. And you can see here that both in conductive and in resistive environments, MobileMT has superior depth of investigation. It's also not affected by these SPM and IP effects, and it has no issues resolving resistivity differences in any range. So if it's very conductive and you have very small changes in resistivity, so like let's say you're in a 100 ohm meter background and you want to resolve something 10 ohm meters, we can do that. Or if you're in 5,000 ohm meters and you want to resolve a relatively conductive feature that's, I don't know, 1,000 ohm meters, we could also resolve that.
And you said you're not the expert, right? Okay.
I'm not. There's much more knowledgeable people than me.
All right. Well, I will not have them on the show because then I will not be able to keep up even. I won't even be able to pretend. Okay. Okay. What would be, as we're walking through it, because this I think will help me understand and by extension, the audience. What would be a challenge? Because I'm seeing on this chart, obviously, the comparison of depth. What would be a challenge that yours would run into? Or let's say, like you said about the industrial, obviously you developed that method and device to counter being able to be in an industrial environment. Yeah. What are some other challenges that you can face when you're dealing with your models?
So with our system, like MTEM is a very, very, very specific system designed for very specific applications, and that system is fine industrial noise. But for a lot of exploration objectives, it wouldn't be well suited. So our system also, in certain if we're in like a built up area, if there are power lines and things like that, it's questionable whether we would be able to, how much our data would be affected, because like I mentioned, sometimes power lines and other infrastructure significantly impact the data. Other times it's limited to maybe only the 60 hertz frequency data and everything else is okay. That's I think a challenge for our system. And in most cases, we work with the people that we're working with to kind of effectively design the surveys so that it minimizes the potential impact of these things. But there's also examples where we've flown over areas that have significant industrial not machinery, but industrial signal and things like that, and we're able to acquire clean data. And part of the reason we can do that is because we record data over such a large range of frequencies. So even if some frequencies are affected, other frequencies are not.
Andrew, going over to you for a sec, can you kind of give a profile of who the customers are? And then to that, in your role, I mean, I'm sure they're probably asking, more educated questions than I would be, but I'm sure you're still running into a lot of people that are trying to understand the technology. So can you kind of profile who the customers are, and then also sort of some of the questions that you're getting on a day-to-day basis?
Sure. So we're dealing with a very broad range of a customer base, and part of that is because of the universality of the MobileMT technology, so we can use it for a wide range of things. We're dealing with everyone from mining houses who are, looking for mineral resources, geothermal, oil and gas people, and they've all got a broad range of questions. So everything from, in my case, I'm more of an operational person, so I'll deal with the operational issues about getting to the site. Can we fly the survey? Are there any safety issues because of the terrain and all those sort of things? And then there'll be some technical issues. And one of the great things about expert geophysics is that we can assist our clients potentially with some forward modelling. So if they have some information about keeping it very simple, if they have some information about their ground, they might have already drilled some holes or have some previous survey data, we can take that information and create a little model that can indicate the effectiveness, the potential effectiveness of our system for the clients. And that's a great tool for the clients because it just gives them a little bit more confidence before, signing on the dotted line, and they can, go to their other key stakeholders and say, look, there's a high chance that this system will resolve what we're looking for, and it's worthwhile going through the process and doing the surveys. So.
Do a lot of, you're still, you're 2018, again, that's not that old of a company. So are you still having to sort of communicate the technology, or is the technology, does it align with the need enough that people sort of, by the time they're talking to you, they have a pretty clear understanding? Or do you have to bring in your team of experts and things like that to sort of walk them through what the process will be, how the data will get collected, what they will see, all of those sort of steps through the process?
So in my role, I give a very broad overview of the technology. And one of the things that we're finding is we're still internally learning about the universality of the system and what it's capable of. And we're constantly communicating that to our clients as well as they learn what the system is capable of. It's not that long ago that an airborne MT system was probably thought of being an impossible thing to do. So I'll generally talk to our clients about that. And then during the process, our processing team, so we've got one of our directors of our company, Alexander, he will be very heavily involved with the clients on the data level, and he will go through the initial model with them. He will talk about how the data is processed. He will talk to them about the products that we can produce, the final data product that we can produce for our clients. Some of our clients are very capable of producing their own products as well. They have their own processing streams and technologies, and people like Alexander and Aamna can talk with them and pass on our internal knowledge and experience with the data to help them with their own processing techniques as well. So
what is the business model? Is it like do you have, we're going to be out here, is it a per case? Like, are you custom building sort of the plan for everybody? Is there sort of these standard things and costs that people are going to do? Like, I'm assuming you're doing all the operation. This is not
sure.
So somebody can't say, hey, I want to rent your equipment for a couple of days. It's not that type of setup.
No, it's not that type of thing. So we're definitely, in all cases, we'll be flying the survey and acquiring the data and doing the initial processing. But different regions have different ways they like to operate. Like in North America, for example, we tend to do a lot of the final steps with the data for our clients. So we'll go into the field and handle all the operations and safety for our clients. Then we'll do the initial processing of the data and then provide a final product. Here in Australia, we work very closely in partnerships with consultancy groups. So they'll come to us and they'll design a survey for their clients.
I see. Yeah.
So they'll design a survey. We will assist them with the design of the survey, as I was discussing before. If we have some information, about power lines and things and any potential issues. But the consultants design the survey for their clients. We'll acquire the data, we'll do the initial processing, and then a lot of the consultants will do their own processing and work and create products which they can interpret for their clients themselves.
And how far is your reach? Oh, sorry, I cut you off.
No. How far is our reach? as in our office here in Australia, or?
Yeah, are you like, would you go do work in Africa and down Latin America and the US, Canada? Like where do you sort of, you're currently, where are you serving? And I guess the part two of that would be, where are you hoping to reach? And after following that question, I'm going to ask Aamna about some projects that you've done. So I just kind of wanted to get a scope before we jump into that.
Sure. So our reach is, our Australian office is only a new office. So I've only been with the company for about 6 months. So I look after Australia and the general Pacific region. I also assist our head office in Canada with projects elsewhere in Asia and Papua New Guinea and things like that, because we all have our own areas of expertise. I'm not a data or technical person, but I have expertise in a lot of expertise in safety and quality management and operations. So I'll assist where I can. We've got an office in Africa, and that's headed by Malcolm Morton, who's a very well-respected name in the industry. So he'll play a similar role to me in Africa. We've flown projects in South America, Ecuador, Colombia, Peru, and Chile. And at the moment, in May, we're flying surveys this month in Canada, the US, Jamaica, Kazakhstan, Papua New Guinea, here in Australia, and Chile.
Wow.
So we've got a lot of systems out. So I think to date, since the company was formed, we've flown 70,000 line kilometres of MobileMT data.
Amazing.
And
yeah, it's very impressive.
Yeah, and look, as far as where we want to operate, we're obviously looking to expand globally, and you know, as we're seeing rapid growth, there's increasing demand, and we're scaling up the company to meet that demand. So
yeah, that's, you know, it's very impressive, and especially since only 2018. I just wanted to kind of, just kind of briefly touch on a couple projects that you've done. Just sort of, I find it with the audience and myself, it sort of paints that picture to go, okay, this is a real world scenario of what it would look like. Do you have a couple projects that you could just sort of briefly outline to sort of give us that sense?
Yeah, for sure. So we recently flew a survey for K92 mining in Papua New Guinea. The Kainantu Gold Project is situated within the New Guinea Thrust Belt, and it's a stretch of terrain that contains high mineralization of gold, silver, and copper. So before I talk about the survey, I just want to paint a picture of the context. So this is a very, very rugged terrain area, and it's also an extremely conductive area. So understandably, a lot of the current or previous EM systems would not have been able to survey this area, but MobileMT was designed to kind of overcome those things. So we flew the first airborne geophysics survey over the entire property in 10 years. And from the results of the survey, first, there's a very known deposit on the property, the Iruma Fimpa Kora vein deposit, and it's the most advanced project at Kainantu. And the results of our survey show really good correlation with their known deposits, but it's also been able to assist the company in identifying multiple new vein and porphyry targets on various licenses. So it's an example where, there was like missing technology in the market to be able to accomplish this. And then with the introduction of MobileMT, we were able to fly a survey over an extremely large area and allow the client to kind of pinpoint new areas where it could be potentially prospective. Another project that we actually just recently flew in British Columbia for Tyrannus Resources Incorporated was a silver, gold, lead, zinc, copper epithermal mineral deposit. And the results of our survey showed extremely good correlation with their known deposits, but it's also allowing the client who we're very much engaged with to kind of expand the area that they're interested in further to the west. And the thing about this project was that, like I mentioned before, MobileMT is capable of superior depth resolution versus other existing airborne EM systems. So in this environment, it was important to be able to image the deep structure. And ground MT is also something that it's been in practice for longer. However, in such a rugged terrain conditions, this is a mountainous area, conducting a ground survey would have been nearly impossible. So again, another gap in the market that MobileMT can help to fill. And then there's a common misconception about magnetotelluric methods in general and airborne MT maybe specifically. I'm not 100% sure about that, but a lot of people think that we can resolve deep, large structures, but not kind of shallow, superficial conductors and things like that. And it's not true. The MobileMT system can do that. And then we also have our MobileMT-M system, which was specifically designed for near-surface applications. So we actually have a case study on our website about flying over a known kimberlite pipe in northeastern Ontario. And it shows that, you know, it kind of like trying to take away a misconception that this technology can't be applied for more discrete structures and things like that.
Well, just as we sort of get towards the end of the interview, I was just kind of wondering, because Andrew touched on some of his, you know, where his training and expertise lies. In your position, what specifically do you do in your role, and what's sort of the background that allows you to do it?
So I am a geophysicist by education and through experience. I have about 5 years of experience now in the airborne geophysics sector. And so I think like that experience, and I've worked in the field quite a bit too, actually acquiring the data. And I think that's a really important aspect of when you are processing the data finally, because understanding what you're seeing is heavily dependent on understanding the conditions under which they were acquired, you know, like potential issues that can arise in the field. And that knowledge really helps to understand the data and then be able to work with it. So it's that experience, it's my education, and then also just kind of learning as I go. Alexander, our chief geophysicist, he's extremely knowledgeable in the field, and he's an extremely good mentor. He's always, you know, teaching me, and then by extension, I'm teaching others about our technique. We're always trying to keep up to date with, you know, the geophysics kind of from an academic point of view, and also the new technologies in the industry and applying new processing techniques, and just always trying to be learning and developing, because I feel like a lot of times companies get very much set in a way, and then, you know, you're not developing and improving. And like Andrew said, one of the biggest driving factors for the people at this company is innovation and just a desire to learn and to always improve what they're doing. So
yeah, no, that's a great answer. And Andrew, going back to you, I'll throw the last question out to you. As I didn't know you were actually new with the company when we started this interview, so that makes it fun to me to wrap up with this. Is what sort of stands out to you? Because once, like, well, Aamna, you just sort of said, if you get in, you sort of get set in your ways and that. So being 6 months in, there's still a lot. You're still, I'm sure, learning a lot about how the company operates, and, you know, sort of building up those networks and relationships and everything like that. What has sort of stood out to you, maybe why you joined the company, but then also what you've seen already as you started to sort of become a part of it?
Sure. I joined the company. I was very excited about the people in the company. So the leadership team, I was very excited about working with them. There's Andrei Bagriansky, he's the president of the company. He's been around for 35 years. He's a very well-known name in the industry. The most exciting thing for me personally was the innovation. We've got probably the best R&D team in the industry. So that's led by Peter Kuzman. I knew of him previously. He'd designed several award-winning systems in the past, the VTEM, ZTEM, and AirMT system. And he's written multiple papers. He's got 20 patents. I also knew of Alexander. He's the vice president of the company. So, and he's a very well-known geophysicist. So the innovation and doing something new and being able to address clients' requirements was very exciting to me, and the support structure put in place by senior management and people like Aamna, there's nothing that's not too much trouble working with our clients every step of the way. It's a very supportive environment from my perspective. So, you know, they're the reasons why I joined the company, and I think they're the true strengths of the company as well. So.
Yep.
Well, thank you, Andrew. I think that's a great way to wrap up the interview, and thank you, Aamna, for kind of walking me through and and being kind about answering some of my questions. It was great to have you both on. I hope this isn't the last time. Even as we sort of got halfway into this interview, I was like, oh, okay, if I was to do this again, I would maybe plan it just a little bit different, so I could sort of unpack it from different angles. But I really want to say thank you for coming on the show. It was a lot of fun having both of you on.
Yeah, thank you so much for having us.
Yes, thank you.
And everybody, thank you for watching these episodes. The support we're getting for our mining show is just absolutely been unbelievable. The support from CIM, sponsors, and the guests coming on, and just the willingness to, you know, the guests that you see coming on, they're doing pre-interviews and writing out notes so that, you know, I can, you know, kind of walk them through information. And they do a lot of work to come on the show and try to share good information with the industry. So I want to thank all the guests, and we've got plenty more episodes coming at you. So please keep subscribing and sharing and commenting, suggesting questions we should have asked for our part 2s, and we will keep Mining Now coming at you. Thanks for watching. See you on the next episode.